This is the Rock 5 Model B by Radza, and it's an ARM single-board computer that's 3 times faster than a Raspberry Pi, and that's just the 8-core CPU. This thing has PCI Express Gen 3, and storage is 7 times faster. I got over 3 gigabytes per second with this Kioxia XG6. That's like hitting Intel 7th gen speeds. It's still half as slow as modern ARM desktops like Apple's M1 Mini or Microsoft's DevKit, but it's way faster than a Pi. It comes with 2.5 gig Ethernet, it has 2 M.2 slots on board, and well, it also starts at $150. So yeah, you get what you pay for in terms of performance. But I wanted to know, for a premium SBC price, do you get a better experience? The thing that turns me off with so many of these Pi alternatives is how hard it is to go from unboxing the board to actually using it, being able to just plug it in, install an OS, and do stuff. But for Linux and for running open source software, how does this board stack up? Is it worth paying $150 to $200 for more premium hardware? Or for that price, should you just go ahead and buy a used tiny mini micro PC like this little Lenovo with a full Intel Core i7 processor, an enclosure, a hard drive, Wi-Fi, and a power supply? And this thing has upgradable RAM too. So how does the Rock 5 Model B stack up? This board uses the latest Rockchip RK3588 SoC with an 8-core CPU, a Mali GPU, a 6 TOPS NPU, and 8K encode and decode. Though besides the CPU, it's not always easy taking advantage of those other features. You can get up to 16 gigs of RAM, and it can run up to 3 displays. It says it can do 8K, though it won't perform amazing running anything on an 8K display, just like the Pi performs pretty poorly when you're running a 4K display. But unlike the Pi, this USB-C port can do DisplayPort output. It has an HDMI input too, but it looks like support for it isn't great yet, if this explaining computers video is any indication. It has built-in 2.5 gig Ethernet, 2 USB 2.0 ports, 2 USB 3.1 ports, and a mini audio jack. Up top there's an E-key M.2 for Wi-Fi or other PCI Express devices, and flipping it over, there's another M.2 slot, and this one is a lot more fun. It's M-key for NVMe SSDs, but if you get a fun adapter like this, you can break out the slot for more interesting things like graphics cards. More on that later. The bottom slot only supports 2280 size SSDs, so if you want to use a shorter SSD, you'll need an adapter. The killer feature is this slot is PCI Express Gen 3 by 4. That means you can get up to 4 gigabytes per second through it. There's also an eMMC socket and a microSD slot, both of which can be used at the same time, and camera and display connectors. The one I bought is the 4 gig version, and it costs about $150, but that's just for this board. It came in this box, and it doesn't come with any accessories. You need a separate power adapter and at least a heatsink. I didn't order the Radza ones initially, so I stuck on this little heatsink and plugged in a 5-volt fan. I wanted to boot the Rock 5 off an NVMe SSD, and apparently you can, but it's a bit tricky and you have to reflash something on the board, so I went with this microSD card plugged in on the bottom. The Getting Started guide on Radza's wiki was helpful, but I was a little worried when it kept mentioning a USB to TTL serial cable. This was my first time using this thing, and it seemed pretty daunting to have to connect to it with a serial terminal if I just want to boot it up. Luckily, I could just plug in a monitor, keyboard, and mouse though. But maybe the Getting Started guide could be a little more focused on just, well, getting started. Leave the complicated stuff for later. I went to the download page and found Android, Debian 11, and Ubuntu images. Once the OS was flashed, I plugged the microSD card in and noticed the tiny slot on the Rock 5 is also a bit of a disaster. You can easily plug the card in upside down, and if you do that, good luck figuring out why it won't boot. I'd rather see a full-size microSD card slot like most other boards have. But now the last thing to do is plug in power. And I didn't have Radza's official 30-watt power supply, so I tried the next best thing, my Apple 30-watt power supply. I mean, 30 watts is 30 watts, right? Wrong. Just like the initial version of the Pi 4, USB-C power can be weird. It's not entirely Radza's fault though. USB-C power delivery is confusing as heck, so I'm not surprised I had issues. The LED on the board flashed blue and green, but the board kept resetting itself. My 61-watt Apple adapter did actually boot, and I also found this thread on Radza's forum that goes way deeper into power supplies than the Rock 5. The FAQ for the board does have a section on power supplies, and I would definitely stick with Radza's recommendation. Just buy their official power supply. I did that, and here it is. Nice and compact, and no problems booting. So once I booted Debian, I saw the kernel seems to be based on Linux 5.10, which is a little strange. When I looked into it, it seems like this isn't even full Linux 5.10. All the Linux images seem to be built with a set of Rockchip patches that are based on really old Linux versions. And on top of that, the first time I tried running updates, I got an error about Radza's apt repository not being signed, but it still let me install software without that. So I started testing things out. I tested the Ethernet adapter with iPerf3 to see how fast it could go and got a consistent 2.35 gigabits down, but only about 1 gigabit up. That's not symmetrical, but it's still plenty fast. Power usage was around 4 to 6 watts on average, and with my little heatsink and Pi fan, the CPU stayed around 30 degrees Celsius. Most things were snappy, certainly faster than a Pi, but I did get strange artifacting on the screen sometimes, like when I opened the terminal and would see these blotchy parts. To really stress the CPU, I wanted to run my top 500 benchmark, the same one I run on my Pi clusters like the Super 6C. But when I went to run it, it kept running into errors with apt. I found this old forum post from November 2020 that had the exact same issue. Luckily, the fix was to manually install a signing key, but that was a bit annoying to have to do right away with a fresh install of the official Debian image. But with that sorted, I ran the LinPack benchmark a few different ways, and it seems the most efficient way is to just use the 4 A76 performance cores, leaving the other 4 efficiency cores idle. That gave me 46 gigaflops using 15 watts of power, so the efficiency is 3.11 gigaflops per watt. And that's a lot better than the Pi 4, and it's almost as efficient on a per watt basis as my Mac Studio. It's just a lot slower than the Mac. I could get a tiny bit better performance if I ran the test on all 8 cores, but the efficiency went down a bit. The slower E-cores are better off just running background tasks. I also wanted to see how things went with different cooling configurations. The CPU got up to 65 degrees under load with fan and heatsink, 82 degrees with just a fan, and started throttling after hitting 85 degrees with no fan or heatsink. But it only had to throttle a little. I was surprised by how well this thing performed thermally. The whole board gets pretty hot though, so I would always recommend at least a heatsink on the main chip. I also ran Geekbench to see how this board stacks up, and the Rock 5 scored a respectable 565 single core and 2384 multi-core. That puts it somewhere between a Raspberry Pi 4 on the lower end and the new Windows Dev Kit I tested a few months ago. It's noticeably faster than a Pi, but it's still not a real desktop class processor. It's not even close to M1 performance, let alone the newer M2 CPUs, but it is a single board computer. It's not really meant to be a desktop. I was most interested in I/O performance. This thing has 4 lanes of PCI Express Gen 3 in this M.2 slot. I've said for years now the main thing holding the Pi back is I/O. I've taken the single PCI Express lane on it to the limit over and over again, and it maxes out at 420 megabytes per second. Well, besides Radza not including an M.2 screw, I have nothing but good things to say here. I installed this Kioxia XG6 drive and it shows up running at full speed with LSPCI. Testing it out with my disk benchmarking script, I got up to 3 gigabytes per second in sequential reads. Even random access was 3 times faster than the Pi, clocking it at 1.3 gigabytes per second. 4K operations are still fast too. Booting from an SSD, however, requires flashing a chip on the board over an SPI interface, and that's not something for the faint of heart. But it's not that much different than upgrading the compute module's EEPROM, I just haven't tried that out yet. We'll get back to the bottom M.2 slot in a bit, but I wanted to flip the board over and test the top slot. This one is A and E key, and it's perfect for Wi-Fi chips like this Intel AX210. I actually just did a video on this chip and Wi-Fi 6E, so if you haven't seen how crazy fast this thing can make your Wi-Fi, go check out that video. But I tried getting it working on the Rock 5, but I kept running into problems. Bluetooth didn't work at all, but I also couldn't install Intel's firmware since there was already some Intel firmware built with the Rock chip sources. The card would show up using Network Manager CLI, but I wasn't able to scan for networks or get connected, and 6 GHz is definitely not supported yet, even though I could get that working on the Pi. But some other people in the forums had it working, so it was probably just a bug I ran into. But moving back to the bottom slot, I wanted to test this. This funky looking thing converts the physical M.2 slot into a normal PCI Express slot, meaning in theory I could plug in any PCI Express device, like this graphics card, because of course that's my kind of thing. I've tried almost every GPU generation for both NVIDIA and AMD on the Pi, and after years of work, I barely got a couple of old cards working. But what about this new board? The Rock chip has PCI Express Gen 3, so a modest graphics card could give a huge boost for video transcoding, streaming, or heck, even light gaming on Linux. And I was really interested in testing out my AMD Radeon card after I saw this tweet. So I did my own testing. After installing AMD's firmware, I ran NeoFetch and, well, it's actually lying here. The GPU driver isn't actually loaded, but since it's connected, NeoFetch thinks it's the active GPU. But it's not. So, of course, I recompiled the kernel. And if you want to commemorate my misery, head over to redshirtjeff.com to get the shirt for that. But after I recompiled the kernel, the Rock 5 stopped booting. The blue LED started blinking and it wouldn't give me any output at all. So for now at least, I put a pin in that. But I wanted to test other stuff too, so I plugged in this crazy little 10 gig M.2 NIC. This thing is made by InnoDisk and it's the strangest network card I've ever used. It showed up with LSPCI, so it was just a matter of getting a driver working. But since there isn't a driver I can download for ARM Linux, I had to compile the driver in the Linux kernel. I do that all the time on the Raspberry Pi, but as I mentioned earlier, I couldn't get my custom kernel working yet. So I put that on pause too, but I want to get back to it soon. 4 PCI Express Gen 3 lanes should give me up to 8 gigatransfers per second, or about 4 gigabytes per second of bandwidth. And according to Thomas Kaiser's research, I should be able to bifurcate the PCI Express lanes, so I could put a 10 gigabit network card and something like a storage controller on here. Assuming the CPU can keep up, this thing could be a pretty powerful NAS, certainly a lot faster than the best Pi setup. To round things out, I also tested some of Radsa's Rock 5 accessories. There's an onboard real-time clock, or RTC, so I bought their battery module. It kind of just hangs off the board, so it would have been nice to at least have a sticker on it. I also bought the fan heatsink combo kit and the standalone heatsink to test. Both worked great, though the fan was a little confusing. When I ran their fan script, it said "trun on fan" in the console, but the way it worked was a little obtuse. I found a more flexible fan control package from PiMumu and used that one instead. At lower speeds, the fan wobbled a bit and made a little noise. At faster speeds, the fan was better balanced and still pretty quiet. The strangest thing was this little packet of thermal goop they included. It looked more like snot than thermal compound. So I wiped that off and put on some of my own. I tested thermals and both coolers worked great, even running a stress test for long periods. With the fan, the temperatures never went above 50 degrees, but with the heatsink, I could push it up into the 70s. Unless you want to push this thing to the max, the heatsink should be fine. I also bought a 32 gigabyte eMMC module and wanted to see if I could use it and the microSD card at the same time, since that's something you can't do on a Raspberry Pi. And on the Rock 5, you can. I also wanted to see how I could flash an OS to the eMMC drive, but the official wiki says you need a special USB adapter, which I don't have. There was a reference to maybe flashing it directly on the Rock 5 on Discord, but let me just take a moment to rant about how much I hate when conversations are all funneled to Discord. It's utterly useless outside of in-the-moment support, and it also means I have to have yet another Discord server muddying up my sidebar just to try to figure out how to use this thing. I mean, maybe I'm just an old man yelling at the cloud now, but I long for the days when people used to have discussions on forums, which were easy to search and link to, and were indexed by all the search engines. But back to the board. I've tested almost everything, so now it's time to compare it to some of its closest rivals, starting with the Pi. This thing trounces the Pi in both CPU performance and efficiency. It's 3 times faster in Geekbench. It also has faster built-in Ethernet, blazing fast M.2 NVMe support, another slot for fast Wi-Fi. I mean, it's in a different league entirely when it comes to the hardware. But the software side still requires a bit more knowledge to actually be productive. And there's still the matter of sketchy Linux support. There are efforts to mainline support for the Rockchip SoC, meaning you could just run plain Linux distros, but those efforts seem to be taking a long time. So right now, I wouldn't recommend this over the Pi to just anyone, at least when it comes to software and support, due to its high price. Heck, I wouldn't recommend anyone pay over $100 for a Pi 4 either, but here we are. But what about other SBCs running the same system on a chip? This Orange Pi 5 uses the same Rockchip RK3588. Well, almost the same. The Orange Pi has the RK3588S, which has a little less bandwidth than the chip in the Rock 5. The Orange Pi 5 only has one M.2 slot running at way slower speeds on the bottom, which means this SSD only gets about 400 megabytes per second, just as slow as on a Pi. The Orange Pi 5 also only has a gigabit port and not even a full 40-pin GPIO header, but it does have a full-size microSD card slot, so that's an upgrade. But the Orange Pi 5 is a lot less expensive. You can get the same CPU and GPU performance at least, and in my case it actually benchmarked a little bit faster for half the price. And moving on to the Khadas Edge 2, I don't have one to test. And that's because it also uses a slower RK3588S, yet somehow costs more than the Rock 5 Model B? Besides the nicer marketing around Khadas's boards, I'm not quite sure why they cost so much. It doesn't have the same kind of community and support as the Pi, it doesn't have the higher specs of the Rock 5, and heck, this board doesn't even include Ethernet, or an M.2 slot for that matter. If you know why Khadas charges so much for their boards, please let me know in the comments. I just don't see the value, especially when Orange Pi has better features for a third of the price. You can even buy a brand new Ryzen mini PC for the price of one of these Edge 2 boards. And speaking of mini PCs, there are tons of these little thin client PCs on eBay. I bought this one with everything I needed, even a Windows license, for 120 bucks. This Lenovo M710Q includes a 4-core Intel i5 CPU, a hard drive, Wi-Fi 6, M.2, and upgradable memory. It's a little faster in Geekbench and a lot faster in Linpack, though efficiency is a little lower. Running Ubuntu, it only uses 8 watts at idle, which is a little more than the Rock 5, but still pretty efficient, especially considering this thing is spinning a hard drive inside. I had almost forgotten how slow hard drives can be. But my point is, once you hit the $100 price point, you're competing with mini PCs like these. And once you go into the $200 and $300 price points, you could even get a brand new Ryzen PC. But in the end, I'm more interested in comparing ARM boards, and the Rock 5 is a huge upgrade over the Raspberry Pi 4 in terms of hardware and capability. Everything is faster, and by a lot. There's tons more I/O at the expense of a little extra board space. But at what cost? Assuming Pis ever become available at MSRP again, and right now that still feels a long way off, the Pi still has 2 major advantages: a cheaper point of entry, just 35 bucks, and better software support. The Linux kernel for all these Rockchip boards is a mess. But focusing on just the hardware, the Rock 5 at 150 bucks and up is in a completely different price class. This tiny PC complete with power supply, a case, a hard drive, and even a Windows license costs less than the base model Rock 5. And that's before you even add in things like a case and power adapter. Rads has done a decent job building up the Rock 5 ecosystem around the RK3588. Besides the Raspberry Pi, this is the best experience I've had with an ARM SBC. But it still has a long way to go before I would call it a Pi killer. Docks need to be more beginner friendly, the community needs to be less insulated in Discord, and the chip needs more mainline support. I continue to follow Radsa closely, and I'll continue exploring GPU support with the RK3588, so make sure you're subscribed. Until next time, I'm Jeff Geerling.